got through it. We survived it. For those of you who may have missed it, if you go to our website, theprototypingshow.com, under the episodes menu, you'll be able to go back, have a look at all the previous episodes, of which there's a grand total of 1. But nonetheless, so we're also today, Charles, we are also streaming to YouTube simultaneously. So for those of you who are watching us on YouTube, just be aware that for the minute we've turned off comments and chat. So if you're over there, I just encourage you, if you want to talk with us and post some comments, feel free to come across to twitch.tv/AWS and you can interact with us here. So Charles.
And how does they usually say? Is like ring the bell, subscribe, and so on and so forth.
Exactly. What I can't even remember what the saying is.
It's probably a like, a bell, and something else.
Like and subscribe. That's right. Like and subscribe. Read the comments. Read the comments below.
Exactly.
Awesome, Charles. What's in store for us today?
So today we're gonna have some super cool things, and again, we took into consideration comments from our auditors from last time, and we have. I think the core of this call today is we talked about some of the tooling that we were using last month and we were contributing to the community. So today we will have some very special guests from the AWS Center of Prototyping Excellence and the ANZ Australia New Zealand prototyping team. And we are going to talk about tooling for speeds.
Tooling for speed. So what does that mean to you?
We talked a lot about velocity of innovations, and having the right tooling is a fundamental. It's almost a backbone of that velocity. Is being able to create the right structure for your project, create the whole environment, create the infrastructure really that would enable you to iterate fast, just focus on building your functionalities and so on. That's really what tooling is about. Yes, and we are using those toolings. We are eating our own food is really something we are using on a daily basis across all the prototypes we are delivering. So I think that's going to be a very cool deep dive into this framework that we have built.
Yeah, I can't wait. I have to say, last month when we were talking with Sarah, it was really interesting. And every time she mentioned code and hands-on, I got really quite excited and was looking forward to getting into some of the deep tech, which I know we're going to touch on today. So, tooling is something that's really close to my heart. And I think it's really a fundamental aspect of achieving velocity that organizations might want to achieve. And obviously, we work with our customers on a very time-constrained basis, anywhere between 4 and let's say 12 weeks, depending on the scope and scale of work that needs to be done. And in order to really do a good job of that and deliver some value to our customers, as well as make sure that we're sort of safe, sound, and secure in everything that we do, tooling is a real key element of that. And I always say, if we have to do it more than once, we should seriously think about automating it. So, from the work that you've done, Charles, with customers, how have you seen our customers sort of look at tooling, and how are they adopting various different tooling mechanisms into their businesses?
Well, as you mentioned, the tooling is built once and then just reuse. They see it as a critical element because human brain is not made to do repetitive tasks over and over again. So building this sort of consistency into the way you are producing new capabilities, new functionalities is something very fundamental. And that's how you're bringing a velocity to your business. So this consistency, the fact that you don't have to, again, automatically you can check the quality of what you are doing and again, have a trust, a confidence into what you are building at speed is really fundamental. And that's how you can iterate quickly, making sure you don't break anything, making sure that everything is fine. So I think that's how they see it as a really valuable mechanism. And compared to previously when they had to, before launching a new functionality, customer had to run a lot of tests, a lot of verification and checks and so on. And being able to remove this layer by automation is also something they're considering as a game changer for them.
Yeah.
What about you? Sorry, Mark.
Yeah, no, that's okay. Look, we see the same thing, right? And there are things that you need to do over and over again. And we really want to be thinking about automating as much of that repetitive, undifferentiated heavy lifting away from the work that we do. So we think about technologies like the Cloud Development Kit CDK, which really helps us to build infrastructure as code really quickly. And, we're going to take a deep dive into that very shortly. One of the things I would also, encourage people to think about, it'd be great to hear your view on it too, Charles, is this idea of sort of incrementalism, which is sort of in Amazon speak is thinking big, but starting small. And then running series of experiments and incrementally learning and just adding small amounts of functionality at a time. And before you know it, a year later, you've got a very well-rounded, well-formed piece of, let's say, infrastructure as code or some custom tooling. Are you seeing that approach in the work that you're doing with customers?
Yes, I mean, we've seen that consistently, actually. Morning my time now, but your afternoon, I was literally in a call and we were doing an executive debrief with a customer when we're sharing about how we've been working iteratively with them, and that they didn't have a very strong use case initially, or they didn't have the full understanding of what they wanted to build. And actually, yes, iteration by iteration, sprint by sprint, we were able to really get the right path through the functionality that we're building. And I don't have yet the result because I jumped to the show, but I've seen some smiles into the face of the customer, and I do believe that we will have some very good feedbacks out of that. So yes, I see it in ASEAN quite often. I don't know about you, because we also have a little bit sometimes of a cultural elements between people who are still, we have a little bit of evangelization still do with some of our customer in terms of the traditional waterfall, and making the customer understand that it is okay not to know from the beginning what they're going to have at the end, because it will give them that flexibility. I don't know how it is in ANZ.
Oh, look, right across Asia Pacific and Japan, we see a diversity of customers at all different stages of maturity on their cloud journey. The thing that I really like about this general concept of tooling is it's a choose your own adventure. You look at your business, you look at the work that you're doing, especially as a developer, right? You look at those things that are slowing you down, that are frustrating you because you need to do them multiple times, things that you're going to have to develop capability on over time. And that's just simply where you start. Now, you can look at off-the-shelf solutions in terms of tooling. You can look at building your own, but I just encourage everybody to look at tooling, right? And really use tooling as a mechanism to find that velocity in the work that you're doing every day.
Yeah,
so
absolutely.
What I'd like to do, if it's all right with you, Charles, is we've been talking a little bit, but there are some real experts waiting in the wings to come and join us. So let me bring on Adrian, Jack, and Marten.
Awesome. Hi, guys.
Hey, everyone.
Hey there.
So welcome, everybody. This is like the first time. Well, it's only show number 2, right? But it is the first time we've had 5 speakers. So this is pretty cool. So everybody, I'd like you to meet some of the amazing folk from AWS. Let's start with Adrian. We'll go sort of alphabetically. Adrian, welcome. Do you want to tell us just a little bit about yourself and kind of what you do every day and why you're here with us?
Okay, yeah, so I'm Adrian Dimmick. So I've been with Amazon and AWS for coming up on 10 years now. So I've worked at AWS and Amazon all over the continental US, Canada, and back in my hometown now in Melbourne. Day to day, I work for the Center of Prototyping Excellence, which is a newly formed team. And recently we've built some tooling, the PDK specifically. So that's kind of what I do on a day-to-day basis. I'm deep in the weeds, coding all day.
Building tools. Awesome. All right. If I get my alphabet right, Jack.
Hey. So yeah, I'm Jack. I'm a senior prototyping engineer here on the ANZ team. I started out my Amazon journey as an intern. Don't look very different to when I started. So I started in London working for Prime Video. and then moved to kind of AWS networking infrastructure, and then most recently to prototyping. So working kind of in the field directly with customers, building cool prototypes with AWS.
And learning from that and helping to build some tools that we're rolling out, not just in ANZ, but right across Asia Pacific and Japan. And even some of those tools are going global.
Exactly.
So
Trying to kind of take feedback from what we're doing and turn those into repeatable patterns and tools.
Oh, patterns and tools. Good Lord, we're going to get super academic. Mr. Payne, welcome.
Hey, Mark. Yeah, Martin. I'm Melbourne-based with Adrian. Been at AWS for just a bit over 5 years now. Started in enterprise support and joined the prototyping team a couple of years ago. I'm here to represent Gen X, so my journey in software started about 31 years ago as a software engineer, and I've done a bit of everything over that time, as you can probably imagine. Yeah, I'm jack of all trades, maybe. Won't finish that statement.
Can I?
Yes.
So we've dropped a few little hints along the way here. We've mentioned CDK, we've mentioned PDK. We've learned a lot from doing hundreds of prototypes over the years with customers. How have we kind of taken that learning? And maybe I'll ask you, Adrian, how have we taken that learning and grown it into a suite of tools? And really, what are those tools, and how are we thinking about tooling at scale?
Yeah, so it's kind of building upon what you said earlier. No one wants to repeat the same thing twice. So, as we're doing these engagements, so, I didn't mention this earlier, but I am an ex-prototype engineer. So I've done countless engagements. And, I've learned, throughout each of those engagements, we typically use a handful of kind of patterns, and then we just build upon them. So, for example, being able to, showcase certain functionality, you need a website. Being able to implement certain functionality, you need an API, and then obviously having a mechanism to be able to deploy all that securely to the cloud. And then, as part of that all, we use many different languages. We don't, have a prescribed language as part of the prototyping team. We pick the best language for the job. But typically we tend to, work towards those higher level languages like Python, Java, TypeScript, Go, etc. So we wanted a set of tooling that works across language, across all of these different kind of patterns and infrastructure techniques.
So just a bit like Martin, right? Jack of all trades across a whole range of languages, and maybe Jack, how do customers kind of think about tooling in their software development lifecycle?
So I think they see it as kind of like a helping hand and almost like a guiding hand to help kind of give them guardrails in building something new, a way to kind of get started quickly, see a kind of an example of how to start and what to build on top of.
And are you seeing it form a core part of their development lifecycle, or do you see it as a side project that engineers are doing?
I think it becomes a core part. I think there's always the side aspect to it as you're kind of discovering and learning new tools, and we see kind of customers doing that and experimenting and kind of seeing how we as a prototyping team might approach a problem. And then kind of choosing the right bits to adopt and grow and kind of become the bread and butter of what they do.
Yeah, amazing. All right, so I'm pretty itchy to see what you guys have got to show. How about we bring up some screens and get a bit techie for a bit? How does that sound?
Sounds good. So just building upon what I said earlier, so we came up with this kind of idea of the PDK, which stands for the Prototyping Software Development Kit. And it's really kind of an extension of two technologies. So we have on one hand CDK, which a lot of you will be familiar with. CDK is a mechanism to declare infrastructure as code, and then it gets synthesized into CloudFormation templates, which can then be deployed via CloudFormation service. On the other hand, we have Progen, which is a templating tool. It allows you to declare project structures as code, similar to how you would in CDK. The key difference being it synthesizes projects. So, on your file system, you'll have, packages, and it can do that in various languages like Python, TypeScript, and Java, to name a few. So what I've got here is I've got a pre-worked example that we've done just to save some time for the demo, because a lot of it's build tooling related. So I don't want to waste your time pulling in dependencies and things like that. But what I really want to show you is some of the capabilities of the PDK and some of the problems that it's trying to solve. So what you see here is it's a mono repo. So when we work on engagements, we typically create a mono repo with all of our different packages. So if I just open up this Progen RC file, so this is the definition of the complete file system that you're seeing here, all of the different packages. So if we take a look, this particular structure here is the NX monorepo project. So this is a Progen construct. And what this does is it sets up the monorepo to use NX as the monorepo build tool. NX is a really powerful tool that allows you to set up interdependencies between different packages. So think of it, Yarn workspace type thing. But it also works across different languages. So for polycot builds, it also supports, a dependency between, say, TypeScript and Python. If you want to build your if you want to build your Lambdas in Python, for example, and deploy them via TypeScript, you can have the TypeScript package add a dependency on Python, and then just rely on the build tooling to make sure things get built in the correct order. This was a massive pet peeve of mine. So when we would work on, particular projects, someone would build something in Python, I would have some infrastructure in TypeScript, and I would have to manually make sure things get built in the correct order, and artifacts get deleted and all these kinds of things, so that the build scripts would be really, really complicated. Whereas now it's just as simple as setting up these package dependencies and then just allowing the tooling to be able to handle the builds for me. The other really nice things that it does is build caching as well. So if I have like a DAG of all my dependencies and I change something at the top level, I don't have to rebuild everything below it. It's just cached. So I'll just keep going and just explain a few things here. So this is all Progen code. So what you see here are a list of dependencies that I'm using as part of the Progen specification. So I'm using some constructs from the AWS Prototyping SDK, which houses stable constructs. So you'll find the NX monorepo in there and the pipeline. And then we have a few experimental constructs that we've recently released. So to be able to deploy a static website, an open API gateway, identity, and a React-based website using Cloudscape. In terms of the actual package structures, we've got an open API gateway TS project. So this is a TypeScript-based project. So if we just have a look at what this synthesizes into, so it creates a whole bunch of files for you, sets up the package, and generates a whole bunch of boilerplate code. And it basically allows you to define an open API spec. And from that spec, it will generate all types. It will generate clients for you. So in this case, TypeScript, but we also support Java and Python clients as well. So if you wanted to call an open API gateway from a Python Lambda, you would have typed Python bindings for that. Jack will get into a bit of details on that later. And then finally, some documentation.
Adrian, just as you're going through this, so this really feels like this is like the top level piece of work, right? This is the project.
Correct.
So you wouldn't have lots of these other little things going on, and you have to manually manage these dependencies in your build somewhere. I think, am I right in saying you have this overarching project, and within that you can define dependencies between different parts, and it just happens to be those parts are some of the PDK constructs?
Yeah, correct. So the PDK is split up into two main aspects. So you have Progen constructs, which are what you see here. So in the Progen RC file, this is where you declare all of the different packages you want. So, if I'm building an API and I need a Python, Lambda or something, I can create a Python package in here, which houses all of my Python code, for example, and then I can set up dependencies on those things. Whereas there's also CDK-based constructs. So similar to like the static website here, I might want to be able to deploy a static website from my infrastructure project. So I'll just declare that dependency over here and then just instantiate it as you would just through regular CDK and stacks and all those kind of things.
Yeah, so it's like CDK is infrastructure as code. The ProGen stuff that you just walk through is really projects as code.
Yeah, 100%. So these are 3 instantiations will generate all of the code that you see within these folders. It sets up linting. It sets up your package JSON file. So none of these files are handcrafted. They're completely generated based on that definition, as you can see here. So git ignores all of those things. We just have kind of basic definitions. So sane defaults, but you can override any of these settings that you like. The other cool thing.
So Adrian, sorry, I know I'm digging in here, but this is super interesting for me. So could you give an example, like if we're tooling for speed, how does this change the velocity of, let's say, a dev team?
So in reality, you could have, so this particular example that we're looking at is a website with an API that's authenticated with Cognito, and it's all deployed via a CI/CD pipeline. When I built this from scratch, it took me 25 minutes. And that's like all the code that you're seeing here. So it's extremely fast. You're saving a ton of time. And yeah, like it's just super fast. Like I just declare all of my high-level building blocks, and then I hook them up. I have a look at my dependency structures to make sure that everything is going to build in the correct order, which you can see here via the graph visualization. And then I just go ahead and implement the business logic that I care about. So I know I have a pipeline. I just need to define my infrastructure that I'm deploying. So a static website, an API, yada, yada, yada. And then just rely on the tooling to just generate all of the kind of wrapper code for me. I don't have to worry about any of that type of stuff anymore, which is super powerful.
So as a business, if I had specific things I was consistently deploying, I could build my own ProGen constructs based on this, and then they could consume my CDK constructs, which maybe have been blessed by my security and infrastructure teams.
Yeah, definitely. So like a good example is the website one, right? So this is a recently created component. This sets up Cloudscape, so it creates like a navigation for you. It sets up breadcrumbs and like a basic Hello World page. So once you synthesize this, it just creates all of that for you. You can actually run it locally and have the website there. You don't have to worry about adding dependencies and doing all this stuff. It just comes pre-canned with a configuration. And then you can just get going writing your components and your pages and things like that, which is super powerful.
Awesome.
That's super cool. I mean, it reminds me when my old days when we were building everything and it was so inconsistent, and it was just, that's so nice to have that. I would have loved to have that a couple of years ago already, but that's pretty cool.
Yeah, we recently used it on a customer engagement, and they were like super happy with it. They're like, wow, this is amazing. We're going to start incorporating it into our workflows. And then like just from a pure like performance perspective, so I've already built this project because I've already deployed it. But if I just run the build command quickly, that is an instantaneous build because I haven't changed anything in any of my dependencies. So that just to demonstrate the power of that, if I make a change to my infrastructure, for example, I'll just add a line there and rerun that, you would expect that only the infrastructure rebuilds, which it does. So the 3 dependent projects are already cached, which is just from a build perspective, you can enable this as a distributed cache and you save a ton of time just not having to rebuild the same things over and over again.
Absolutely amazing.
Cool. So then in terms of, I'll just finish off this little section and then I'll hand over to Jack to just get into a little bit of detail. So I mentioned the website already. So this is a Cloudscape-based website. Cloudscape, for those of you who don't know, is a brand new UX design framework that was recently released, I think like maybe 3 weeks ago. And it provides, a ton of components like tables, tabs, like the typical kind of UX components you would expect from something like Material UI, Bootstrap, those types of things. And then finally, we have this PDK pipeline TS project. So this is a kind of pre-canned pipeline in a package type construct. So what you get out of this is a package that contains a basic pipeline for you with a single dev stage. You can obviously add to this at a production stage, manual approvals, integration tests, all those kind of things. It also comes pre-canned with PDK nag enabled, which is just a very thin wrapper around CDK nag. So as you're writing your infrastructure, you'll continuously see warnings or errors if you're creating, say, like insecure S3 buckets or things like that. And, obviously you can suppress them or fix them, whatever you like. And then
So
from
you're doing
here,
so that's like some preventative controls that you've got in there.
yeah. So CDK NAG is a tool that basically has a look through all of your resources and just make sure that settings are configured based on best practices. So making sure you have encryption enabled, key rotation, things like that. I also, I'm not sure if I mentioned this earlier, but all of the CDK constructs that are vended by the PDK are also cross-language. So they compile into Python, TypeScript, and Java to begin with. So if I just drill down quickly into this, so in terms of the pipelines, we have a pipeline, we have a stage. Within the stage, you have a stack. So typically, this is where you would start implementing your infrastructure. And then I'm just going to hand over to Jack now, who's going to actually walk you through the CDK configuration setup of this example.
Yeah, fantastic. Thank you. So this stack is where we define our infrastructure that's going to be deployed by the pipeline. And so for this kind of basic example, we have a website. So we use the PDK's static website construct. So this is setting up an S3 bucket, which will host our built website static assets. We have a CloudFront distribution. We have WAF in order to kind of secure requests to CloudFront. So all of that is kind of created behind the scenes by this very simple construct. It also provides a way to pass some runtime options in, which are essentially kind of values which your website can have access to from your infrastructure. So we might have an API that the website wants to call, so it'll need the URL for that API, so it knows where to send requests. Then kind of working backwards from the website for part of this kind of demo project, we want a way for users to be able to log into our website and then make secure requests to an API. So the PDK provides a user identity construct, and this sets up the Cognito user pool and identity pool and user pool web client in order to allow users to log in to the website. Then we have the sample API here, which is actually completely generated as well by the PDK when you create that Open API Gateway TS project. And just here we have the kind of permissions to allow authenticated users to call the API. So I wanted to jump into a little bit more detail about this API and how all of that works. So as Adrian mentioned, a very common theme across our prototypes is kind of every prototype ends up with an API. And we wanted to remove a lot of the kind of common mistakes and kind of heavy lifting that one might do when you create an API and just allow you to get kind of stuck into the business logic. So things like type safety is really important. So you want to be able to declare the inputs and the outputs for your API and kind of provide that contract for clients, but also for servers to implement it. So I'm just going to jump in a little bit to this API package, which was...
So you just said something really interesting, Jack. So you said for machines as well. So you're saying what's being built here supports both the human authentication and maybe even authorization as well as machine to machine?
Yeah, exactly. It does. So you can kind of choose your own adventure in terms of how you authenticate your APIs, and then users can kind of call your API either kind of using whatever authentication mechanism you set up. So that might be Cognito for kind of a user to log in and make requests, or it might be something like IAM, which could support either users or machines calling your API too.
Awesome.
And through that vending type-safe client means that kind of developers who are writing code which might interface with your API, they can kind of see straight away in their IDE what inputs they need to provide and what outputs they can expect.
Hang on, you're using big words, Jack. Type-safe client. So are you saying this also generates like an SDK that I can use client side to talk to the API?
It does indeed. So it starts with an open API specification. So this spec.yaml file. So this one gets generated for you with a hello world API. And this is the source of truth for all of your operations. So the paths and HTTP methods, all of the kind of parameters, whether they be query parameters or a request body, and then all of the different responses that you can send back, all with kind of schemas and exactly the structure that you can expect to get back. And from this kind of single source of truth, we then can generate a bunch of things. So one of the things that we generate is this type-safe client or SDK. So I'll show you in a little bit how the website makes use of that to call our API. So as well as this, the generated clients, you also have documentation as well. So you can write kind of descriptions for all of your methods in here and have all of this nice, pretty HTML documentation generated. And all of the infrastructure generated too. So one of the quite cool things about this construct in the PDK is that you get given an API construct, which you can then extend. So here's a sample which extends that. And here, it's essentially taking the API in your spec and then providing a few extra parameters for that. So you can choose how you want your API to be authenticated. So in this case, we're using IAM, but we also support kind of no authorization or Cognito or a custom kind of Lambda authorizer. Then
Hey Jack, just we're getting some interesting comments coming in. So I asked everybody, you mentioned YAML, right? And I just, so I asked everybody braces or spaces, mate. I have to tell you, here's the audience result, braces all the way.
So we can have a look at adding kind of JSON support. That wouldn't be too difficult if you want to define your API in JSON. And actually that brings us to a kind of future thought that we're thinking for this is, what if you don't want to define your API with OpenAPI? We could actually implement a Smithy interface. So there's a very cool kind of interface definition language with Smithy, which is another tool built by AWS that lets you kind of define all of your models and operations. And it's protocol agnostic, but we could easily have it generate this kind of thing as well. Let you get started with your infrastructure and clients. So through this construct here, we actually use the operations that you've defined in your specification to make some type-safe a type-safe interface even to the construct. So you can actually even, for example, if you omit an integration for a particular operation, you actually get a type error because you need to implement the Lambda function which will service that particular operation. And at this level, you can also add an authorizer if you want to change how a particular operation is authorized. And then, so as well as adding this kind of type safety around building your infrastructure, the clients that call the API operations, We also add a bit of type safety on the server side as well as you implement kind of the business logic for an API. So generated for you are also these handler methods. So these are essentially wrappers which take a function, and that function must implement the API contract that you've defined in your Open API spec. So here we get a nice type-safe interface. So all of the requests and responses are marshaled and demarshalled for you, turned from the kind of raw HTTP requests into the input types, which you've defined in your spec. And then you get type safety for your implementation. So for example, this say hello operation, we've said that for a successful response, we're going to return a message. So if here, if I comment out the message and stop returning it, we actually get a type error to say that we're missing this message property. So it becomes kind of really, really powerful having all of this type safety and moving those problems as far left in the development cycle as possible using type safety. So awesome. That was probably a bit of a whirlwind. Any kind of questions or thoughts before I jump into the website stuff?
That was a whirlwind. We are getting some comments. Wook J said, "Cool." Hey Wook J, welcome. What you really want to do is download it, use it, figure out what constructs, whether they're CDK or their Progen constructs, are best for your business. And contribute them back, right? This is an open source project, right?
Yeah, that's right. It is open source. We really wanted to make it open source. Like that was like literally the first thing I decided on, because I want customers to be able to use the same stuff that we do. So like, you know, that was like definitely one of the main driving factors behind it.
Awesome. Okay. So where are we going next, guys? You said it's choose your own adventure. Can I pick maybe have a look at a website?
Yeah, absolutely. So the website, again, through the Progen RC definition, Adrian showed that declaring a Cloudscape React website gives you all of this code. And in the source folder, you can find all this stuff set up for you. So a login page with to allow users to log in to your Cognito user pool in order to then be authenticated. It also sets up an app layout and routing. So there's lots and lots of kind of code that you get set up with so that you can just start building your website. And so through this, in order to actually set up this demo where we have a website which calls our Say Hello API, all we really had to do was define a kind of hook to instantiate our type-safe API client. So that just takes some basic parameters like the URL of the API to call, a pointer to the implementation of fetch, which is used to actually send the requests in the browser, and then some middleware, which is for authenticating requests. So here for our API, we're using IAMAuth. So we want to sign our requests with SigV4. So we use this middleware, which is vended as part of the default website. Then all we really had to do after that is in the homepage, actually call our API. So we make use of it here in a use effect, which is going to run as the page loads. We're just making a call to the API. Here, this is the type-safe client. So we see that we'll get a type error if we don't pass in a required parameter. When we get the result, that's all type safe. So we get auto completion on what we get back. Here, we're just setting that in a state variable. And then finally here, we're saying if there is some text that we've got back, we display it on the website homepage. Otherwise, we just show a spinner as it's loading. So maybe I'll hand over to Adrian, who can show you the finished product with all of these pieces stitched together.
So before we do that, we've had a question. I need to know your IDE color, theme, and font.
So vital
How about
question.
we'll post that to the show notes. How does that sound?
Yeah,
I can send you a
definitely.
link. It's Nord it's in IntelliJ. You can also get a Z shell theme for it as well. So my IDE and terminal and everything is just skinned that way, which is pretty nice.
Adrian,
Is that
very
NORD, Adrian?
NORD, yeah. It's like a Scandinavian theme. Cool. So I'll show you briefly the website. So I'm just going to log in. So I've pre-created a user incognito here. I'm just going to log in. And as part of that static website / user identity construct, it comes pre-configured with MFA. So I'm just going to just type in the code right now. We just got a text message. And there we go. So that was an API call populating hello prototyping show. And that was called through the TypeSafe client. And then this is the base website that you get. So you had the login, you've got your username up here, sign out button. You've also got dark and light theme as well, along with density as well. So if you want a more compact layout, you can also set that up there. In terms of like the pipeline that was deployed, so if we take a look at the pipeline that was instantiated through that PDK pipeline TS construct, it sets up the code commit repository. It sets up a build job, which runs that build all command. So it'll build all of your projects in dependency order. Self-mutate is basically if you update the pipeline definition, it will update it here. Assets. So this is basically any asset that you want to deploy as part of your infrastructure. So in this case, the website bundle. And then finally, the dev stage. So it will prepare a change set and then deploy the change set. So as part of that change set, we get the CloudFormation distribution, and then that's what I basically showed you. So if I just copy and paste that again, that's the website right there. So as you can see, like this website. So as I mentioned earlier, it's Cloudscape based. So Cloudscape, as I mentioned, is a recently open source product. It has a whole bunch of components, as you can see here, that you can start playing with and start adding to your base project. And then just another thing I wanted to mention was just in terms of docs. So all of the docs for every construct and every single like progen construct and things like that are all listed as part of this website, which you can link to from the GitHub repo. And it contains like fairly detailed descriptions on how to spin things up, how to configure them, and how to use them. And it also does that for every single language. So if we take a look at this one, for example, that's how you would do it in the various different languages, which is quite nice. In terms of the code that we just showed you, so the sample code actually lives within the prototyping show branch within the PDK GitHub repo. So you can actually clone this locally and have a play with it. Alternatively,
so
if you want to...
So Adrian, just before you go, so you're saying in that branch is all of the code that you just went through in the last few minutes. So if somebody can bring that branch down, they can have a play with what you just demoed.
Yeah, so they could just pull this down and deploy it to their account and just have a website up and running. Alternatively, if they want to build it from scratch, so with an empty canvas, they can just follow the steps in here to create a monorepo, for example, and then start adding all of the dependencies and all of the steps to add the things one by one. But basically what you see on this page is everything you need to do to be able to get to where we just got to.
So it's like a good sort of quick start, or sort of getting started type thing. Figure your way around the PDK.
Correct. Yeah, it's a good way just to play with it. And then finally, like in terms of contributing, so we've got a contribution guide here. So if people are interested in creating PRs for their own constructs, we'd love to see it. And then there was mention earlier of people wanting to use JSON instead of YAML. So you can just create an issue in here or a feature request rather, and then we can take a look at it and prioritize it accordingly.
What do you reckon, Charles?
That's super cool. I mean, I love it. Obviously, super powerful, speed, guardrails, security, best practices. This is an awesome tool for everyone, I guess. So very, very cool, guys. And so my question will be, what is next then? Because Jack, you mentioned that potentially it will be something about Smithy interfaces versus OpenAI. What do you have in the pipeline to make it even better?
Yeah, absolutely. So Smithy is one as just a kind of alternative option for defining your API, and then also Smithy recently released the Smithy Server SDK for TypeScript, which is a way to implement your Lambda code in a similar fashion with kind of type-safe inputs and outputs for your Lambdas. So we'll probably look at how we could make use of that as well as an alternative. There are a bunch of other cool things we've got.
Yeah, another one was that we just want to improve the security posture of each of the CDK constructs. So they're already quite secure, but we want to just take it to the next level. That's one thing. And then another thing is also declarative app sync. So in the same vein as the declarative open API stuff, we want to be able to just define like GraphQL types, have that just pump into a construct that generates all of the resolvers. You can even implement them initially. You can just pick your implementation like Dynamo or whatever and actually generate all the code for you. Or if there's certain things you want to override, so like you want a query, for example, and you actually don't want Dynamo, you want OpenSearch, then you can just plug in a Lambda and have that have that just hooked up. So, the main goal of the PDK is focusing on writing code that matters and not caring about, how you set up infrastructure. So we're just trying to take that level of abstraction one level higher.
That's cool.
So
we have one comment. Yes, we have a comment actually from, I don't know how to pronounce.
Gotti121.
Okay, sure. You may have already answered this, but when would you use this over something like AWS Amplify? So please go ahead.
Yeah, so one key advantage, there's actually two key advantages. One is you can just declare all of your code, all of your project structures as code. So you have more control over there. We're not super prescriptive about it. So if you want to have an escape hatch, you can override certain settings and things like that. The other advantage is we built it with cross-language in mind. So each of our constructs compile into, like I said, Java, TypeScript, and Python. And we can add support in the future for Go. We can add support for C#, all of those things that are supported by the CDK. So that's one of the key advantages. And the other thing is like we try and remove as much magic as possible. So we want to give control to the developers. With the static website, we generate a bunch of code, but you also have the option to change it. It's abstracted, but also you have the capability to override whatever you like. Which is something that I think is important.
Super, super cool. Thank you very much, guys. Thank you for your time. Thank you for the deep dive. It's really awesome. Again, for our viewers, there is a lot. There is another question, actually. Perfect. So if I've written my UI in TypeScript, can I write my server-side Lambdas in a different language like Java while still leveraging the API's type safety?
You can indeed. So right now in PDK we support both TypeScript and Python as kind of type-safe Lambda languages, but Java is another one that's on our list coming soon. So watch this space.
Yeah, just like a very quick example, like to do that, you would do something like new Java project, and you would just fill in the details there, and then as part of that, you would add a dependency on the generated client, so similar to this.
Yeah.
In this case, it would be the generated Java client, which you can generate as part of the Open API Gateway project over here. That. And then your Java Lambda now has access to that generated client, so you can call those APIs, and then you're good to go. So yeah, totally can be done. That's one of the main objectives of that. Exactly.
Well, and maybe someone can join and participate and start working with you on that. Again, it's an open source project, so
perfect.
let's move forward. Mark, thank you so much, guys. Really, really cool to have you and to have you share about the PDK. I think that's really awesome. So thanks again for participating to the show.
Yeah, and just one thing before I go, I forgot to mention, if anyone else has these kind of questions, feel free to post them in the discussions board on the PDK page, and then we can actually respond to you with an example, snippets and things like that to get you started as well. And then that way the next person will have that as a reference.
Awesome.
Fantastic. Thanks, guys. Great to see you all.
Thanks, everyone.
Thanks very much.
Thanks, guys. Cheers.
Right.
Very cool, Mark. Very cool.
Man, that's incredible. If I would have had that like 6 months ago, it would have saved me hours and hours and hours. So that's fantastic. So Charles, what's next?
What's next? I think is it our code commit challenge? Would that be?
Yeah.
And did you find something funny today this month?
Yeah, indeed. So I'm a bit of a Bon Jovi fan, so I thought this one was awesome. Shot to the heart, and you're to blame. I gave this class a bad name.
I love it. I have the music sounding in my mind.
I almost want to start singing. Exactly. I almost want to put on the electric guitar and have a play and a good sing. But there is something hidden inside of this, right? Which is how you name things is actually really important. Right. When we write code,
it doesn't look important on the moment, but a few months later.
Well, as we were just talking about, like in terms of speed and velocity, you want to make sure that what you're writing is legible, like you'll do, when you write with your hand. But also, more importantly, is that when you are no longer maintaining that code, others can read it and sort of intelligently infer what the code is that you've written. Now, some people have their different views around whether we should have comments in code, for example. I think we should be using, my opinion is we should be using those sparingly, and the code should read like a book, right? It should tell its own story. So you don't really want to give classes bad names.
Well, imagine in the PDK, actually, if you start to have your a front end who calls some APIs and you have no clue what the API does, it's waste your time. While if you have a very precise name, you know where to look at. So absolutely.
Yep. Well, you know what they say about, computer science. There are only really two hard things, caching, validation, and naming.
Yeah, if only. I wish, but
if only. So, Charles, in our last episode, we stumbled across. It was a little bit of a teaser, right? Like we stumbled across something that was super interesting in our "We Failed, So You Don't Have to," and maybe I'm going to bring. Actually, I'll bring Martin Payne back to join us. Martin, do you want to come back and join us? I think this would be a little bit of fun. So, one of the things we kind of identified. So one of the things we identified, Charles, is there's a bit of a legacy here of things that have gone on in hotel rooms during various travels that have led to failure. So I can see Martin's about to have a breakdown.
Vegas stays in Vegas, Mark. You know that.
Yeah, well, I did give a teaser. So what you see in front of us here is actually a piece of hardware that is a 737 simulator that we built for reInvent in 2017. Now, 2017, long time ago. That was when we were young and energetic. Now, we couldn't obviously, we didn't ship this sort of to where we were. We went to where it was. So we shipped it from Canada to Las Vegas, and we had this set up, in our hotel room. And what we were doing with it, with this was we were actually using what was or what is now known as SageMaker, and we were training the simulator to be able to fly approaches into an airport. Now, what actually happened was we were sitting there. We heard a bang, bang, bang at the door, and we actually got a visit by Homeland Security, and I can see Martin
Yeah.
wincing. So we're in Las Vegas. A couple of very fine gentlemen with very large guns on their hips came to visit us to find out what two Australian guys were doing.
We were pretty rough looking by that stage, Mark. You're glossing over some of the details that justified the concern.
Exactly. But I would say that was an incredibly terrifying experience to have Homeland Security knock on the door. I thought they were going to take my passport, but they came in. We explained what we were doing, why we had a simulator. They had a good look through it. And on their way out, they actually said to each other, "Wow, that's really cool."
That's really funny.
Exactly. So it's not really a case of where we failed. We had a lot of really good outcomes from this demo, and we learned a lot. But I think we failed in kind of some social understanding of the social environment of having flight simulators in a hotel room. So that was quite an interesting experience.
That's hilarious. I had also an experience, and we may be a little bit short on time again. I'm sorry, then. So it's another teaser for next time. I had an experiment that literally exploded in my room after I got out to the US, and the immigration officer believed that I was smuggling drugs into my computer screen. So start knocking everywhere to figure out where the drug was. And obviously, I didn't have any drug. But yeah, I start doing my robot bartender, my cocktail my robot bartender in the room and check everything. And I start having a big explosions when I was invited for a super executive dinner. I've got flown in business class and everything across the world, and I had nothing else to show anymore. So it was a little bit of a moment of doubt, I would say. The moral was that, careful, the voltage is different in the US.
So it exploded. Hey, Charles, I don't want to cut you off, but we
have to. Absolutely.
I want to thank everybody for joining us again. Also, just a big call out for next month's prototyping show. We have Ashish Rajan and Darren Boyd joining us. Ashish is a cloud security guru, as is Darren Boyd. We're going to talk about security at scale and security at pace in prototyping. So thank you, everybody, for joining us. Thanks, Charles. Thanks, Martin. Hope everybody stays well. And we will see you next time on the Prototyping Show.
Thanks, everyone. Thanks, Mark. Have a great evening.
Take care.